Welcome back, everybody. This is our seventh session in JEE Mains previous year questions for chapter Alternating Current of class 12th. Before this video, we have made 6 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for neat previous year questions. So if some of your friends are preparing for that, you can guide them through those videos, and those videos are also available in our YouTube channel's playlist section. And if you find these videos useful, helpful, then do press the like button, share them, and subscribe to our channel. Also, if you'd like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. And in the previous one, we completed up to around 40, I think. This was the last question. Let's move to the next one. So question number 42. Let me adjust pen thickness. Now in the circuit here, the voltage across E and C are respectively 300 volt and 400 volt. The voltage E of AC source is. So we have to find out voltage of AC source. Now as both of these instrument means both inductor and capacitor are in series, it means a same current will be flowing through both of these. And if we consider them as an individual circuit, let me show you how. Suppose I consider only inductor here. So in case of only of inductor, circuit will look something like this. This will be the circuit in case of inductor only, and in case of capacitor, circuit will look something like this. Now I'm assuming that this battery source does not have any resistance and wires are also free of resistance. So now if I draw a voltage versus current curve here, same for this circuit, voltage and current curve. So suppose here I am representing amplitude and here I am representing time. Suppose we have a sine wave of voltage. So voltage will look something like this in both of these, because now they are independent circuits. But we know in case of inductor, our current lags behind the voltage. So our current will be something like this. If I draw here some lines so that graph can be okay. So our current in case of inductor will look something like this. Something like this will be the curve of our current. Means here current is lagging behind by 90-degree, and in case of capacitor, currents lead behind 90-degree. So in case of capacitor, current will be something like that. It will be starting from here and will be going something like this. Wait a minute. It will go something like this, and here we will have the peak, and here we will have something like this. So something this like of behavior will be shown in case of pure inductive and pure capacitive circuit. Now we have attached both of them in series, and now we know that when some circuit, or when we can say some elements are in series, so there is a same amount of current flow through them. So current in this inductor and current in this capacitor will be in the same phase. So if they are in same phase, suppose this arrow up represents our current. Now in case of inductor, the current lags behind voltage, means voltage is ahead of current. So we can say here this will be the voltage of the inductor. And in case of capacitor, current is ahead of voltage, or we can say voltage is behind of the current. So in case of capacitor, voltage will be something like this. And we are taking here pure circuit, so this angle phi will be 90 degree in both of the cases, as we have already studied that in case of a pure inductive or pure capacitive circuit, phi is 90 degree. So here again, if we are comparing their individual voltages, so their phi's will be of 90 degree. So now we can see that both of the voltages are out of the phase. Both voltages are out of the phase, and the actual voltage in the circuit will be their modulus, sum of their modulus, or subtraction of their modulus, difference of their modulus, because they are out of phase. So we can say Vc minus VL modulus, and that will be, suppose 300 minus 400 modulus, that will be 100 volt for us. So option C will be the right answer. If we have a resistance and capacitive circuit, then we get a different expression here, because in that scenario, for a resistance, voltage and current are in the same direction. For that, phasor diagram will look like something like this. We will have VR here and VL here. Then we will get a resultant voltage, that will be VL square plus VR square. But if we have inductor and capacitor, then both of their voltages are out of phase. So we will be taking their sum according to their directions. Let's move to the next one. A resistance R and capacitance C are connected in series to a battery of negligible internal resistance through a key. The key is closed at t is equal to 0. After t second, voltage across the capacitance was 7 times the voltage across the resistance. The value of t we have to find out. So let's slide it. And we have resistance and capacitance circuit. So this is resistance, this is capacitor, and we close the circuit at t is equal to 0. So this is our basic circuit. Now in case of capacitor, capacitor will be in the charging state, and in charging state, equation of charging for capacitor is given by q is equal to q node 1 minus e minus t by tau. This is the charging equation for the capacitor, and it is mentioned that voltage across capacitor 7 times voltage across the resistance. So to find the voltage across both of these, we need the value of current, and current can be calculated using derivative of this. So I is equal to dq by dt will be q node 1 derivative 1 is 0 e raised to power minus t by tau into minus 1 by tau. So that becomes q node negative negative positive e minus t by tau divided by tau. We know that tau is equal to RC. So q node e raised to power minus t by RC by RC, and q node is the maximum charge that a capacitor can have, and that is equal to CV. So further it will be CV e raised to power minus t by RC divided by RC. So C get cancelled and we get V by R E minus t by RC. This is the current flowing in the circuit at any time t. We will put the value of t, and we will get the value of current at that time t. Now as per statement, voltage across capacitor, or we can say voltage across capacitor, is equal to 7 times voltage across resistance. Now, voltage cross capacitor depends upon the value of charge at that time, because for capacitor, Q is equal to CV or voltage is equal to Q by C. So it depends upon the amount of charge at that time and amount of charge at any time given by this equation. So VC will be Q node 1 minus E minus T by tau is already RC. So it will be RC divided by capacitance C is equal to V by R, 7 times of V by R, e raised to power minus T by RC. Now we know that Q node by C will be equal to V, because potential is same here. So we will have V 1 minus E T R C is equal to 7 V by R e raised to power minus T by RC. And oh, I forgot here to multiply by a resistance, because voltage across resistance is current times resistance. So this is the current and this is the resistance. So voltage time resistance. Now R get cancelled and V get cancelled. So basically we have 1 minus E minus T by RC is equal to 7 e raised to power minus T by RC, or I can write it like this: 1 is equal to 8 times E minus T by RC, or 1 by 8 is equal to e raised to power minus T by RC. Taking antilog, we will get 8 is equal to T by RC. Sorry, ln 8 is equal to T by RC. And from that, T is equal to RC ln 8, and ln 8 can be written as RC. 2 raised to power 3 is 8, so it will be 3 RC ln 2. That is option A for us. Let's move to the next question. In a LCR circuit shown in the following figure, what will be the readings of the voltmeter across the resistance and ammeter if AC voltage of 220 volts 100 Hz is connected as shown in the figure? So we have to find VR and current in the circuit. For that, first we can use formula that Vrms is equal to VR square plus VC square minus VL square. Now VL, or voltage across inductors, is 300, and VC is voltage across capacitor, that is also 300. So in short, both are equal. So Vrms will be equal to VR square under root, and from this Vrms is equal to VR, or VR is equal to Vrms, and VR will be Vrms, that is 220 volts. So 220 volt. And now coming to the current, as we can see that both of these values are equal. Voltages across inductor and capacitor are equal, means Xc is equal to XL, or system is at resonance. And at resonance, we know current is given by Vrms divided by Z, and that Z is equal to resistance. So 220 by resistance, that is 100, so it will be 2.2 ampere. So option D will be the right answer here. Let's move to the next one. A fully charged capacitor with initial charge Q node is connected to a coil of self-inductance L at T is equal to 0. The time at which energy stored equally between electric and magnetic field is. So we have to find that energy stored equally between electric and magnetic field. For that, first of all, we need to know the formula for energy stored in both capacitor and in case of inductor, because we know that in capacitor energy stored in form of electric field, and in case of inductor energy stored is in the form of magnetic field. So for capacitor energy stored is half CV square. This is for capacitor, and for inductor it is half Li square. And we have to find the time. So it, as per mention, that both are equal. So half CV square is equal to half Li square. So half get cancelled. And from this we can write that CV, that we can write, okay, we will use different formula here because we have to compare charge. We have current here, so we will try to have a charge on this side. So we will use Q square by 2C. So Q square by 2C is equal to half Li square. Again, half get cancelled. And from this, we can write that Q by I square is equal to LC. Or we can say Q by I is equal to root LC. This is our condition. Now we know that initially capacitor is charged and it is discharging. So charging equation for capacitor will be given by a discharging equation, that will be Q is equal to Q node e raised to power minus t by RC, where RC is the time constant. And capacitors need to be discharged to its half value, because only then there is possibility that their energy will be equal to each other. Why? It is mentioned that we have a capacitor and an inductor with it, and at some time they have equal energy. It means half of the energy, half of the energy that capacitor had is now stored in inductor. So we can say now now capacitor only have half of its initial energy. So initial energy of the capacitor was Q square by 2C, and final energy is, let's say final energy is Q dash square by 2C. Q dash is the charge at that time, and it is half of original energy. Original energy is Q square by 2C. Capacitance stay the same. So 2C get cancelled, or we can say Q dash is equal to Q by root 2. Now Q dash is the charge at any time t, and it is given by this equation because capacitor is discharging here. And let me write it Q node, because we have assumed that maximum charge will be Q node. So this Q should be equal to Q node times e raised to power minus t r RC. So it is equal to Q node e raised to power minus t by RC. Q node get cancelled. Taking antilog, we get ln root 2 is equal to t by RC, and times comes up to be RC ln root 2, and we can further write it like half RC by 2 into ln of 2. But as we can see that none of the option is matching, and also we have something like root RC. So we have to change something here slightly. We will use this formula here. Now we know that, let me write it here. First of all, this The exact formula is q is equal to q node e raised to power minus t by tau, that is time constant, is the charging time. And if we use this one here, we have q by i, q by I is equal to root LC, and this I is q by t already, so it is q by t already. So let us write it as a time constant. So time constant is equal to L by C under root LC, and now we will use this value here to solve this equation. So we had that q dash is equal to q node by 2, and then we will write it like q node e raised to power minus t by time constant that was originally RC. We now have it as root LC. So root LC, and this is root 2 here. Now we will try to solve it. So q node gets cancelled. Taking anti-log, we will get root 2 is equal to t by ln of root 2 t into root LC, and from this root LC into ln of root 2, and we can write it like this, that half ln 2 into root C. Now ln 2 is 0.41, so not 0.41, ln 2 by 2 will be give us 0.173 into root LC. Now the nearest match with the all the available, we know that pi is 3.14, pi is 3.14, and if we divide it by 4 we will get something 0.75. So the nearest match is this one, all are other are greater. So we either none of the options is correct, or only option A fits to the nearest match criteria. Let's move to the next one. A resistor R with 2 microfarad capacitor in series is connected to a through a switch of 200 volt direct supply. Across capacitor, a neon bulb that lights up at 120 volt. Calculate the value of R to make the light bulb light up 5 seconds after the switch has been closed. So first of all, let's draw the diagram, the circuit diagram, then we will be understand it better. So we have a resistance here, that is R, and we have a 2 microfarad capacitor here, and it is connected to a direct supply of 200 volt, means DC. We have a DC battery here. Now across this capacitor we have a neon bulb that lights up at 120 volts. So suppose we have a bulb here, and this bulb lights up at 120 volt, means when it gets 120 volt it will start glowing. Now we need to adjust the value of R such that after pressing the after turning the switch on, or after attaching battery in this circuit, this bulb should take 5 seconds to glow. Means the voltage across bulb should reach from 0 to 120 volt in 5 seconds. Means voltage across the bulb is variable. Now voltage across the bulb is also equal to or also same as voltage across the capacitor, and as we have battery connected in the circuit, so we know that capacitor will be in the charging state, and charging equation for capacitor is q node 1 minus e raised to power minus t by tau. This is the charging equation for capacitor, and voltage for capacitor will be given by, voltage for capacitor is q by c, and it will be q node by c 1 minus e t t by tau. This is the voltage for capacitor, and as per mentioned that it is equal to 120 volt at any time t, and that time is 5 seconds. So q node by c is equal to original voltage or v node, because q is equal to cv, and when capacitor is fully charged means voltage it at its maximum value, so it is cv node. So we can say q node by c is equal to v node, that is the original voltage, that is 200 volt. Now some of might get in some of you might get in doubt that we have solved some questions in the previous questions. In some question there was some voltage drop across the inductor and some voltage across the resistance and some voltage drop across the capacitor. So how now this whole 200 volt is dropping across the capacitor? So in those circuit we had a AC power supply. In case of AC power supply, there is a we can say finite resistance of capacitor, but in case of DC power supply this capacitor has the infinite resistance, and how all of the voltage drops across capacitor, because finally there is no current in the circuit. When capacitor is fully charged there is no current in the circuit and it breaks the circuit, so all of the voltage is dropped across the capacitor. That's why we take here v node as capacitor when it is fully charged. So q node by c is v node, and v node is equal to 200. So 200 1 minus e minus t tau is equal to 120, and from this 1 minus e minus t by tau is 120 by 200, that will be 3 by 5. So 1 minus e minus t tau is equal to 3 by 5. Further adjusting, 1 minus 3 by 5 is equal to e raised to power minus t by tau, or 2 by 5 is equal to e raised to power t by tau. Now we can write it like taking ln of both sides or anti-ln. So it will be ln of 2 by 5 is equal to minus t by tau. Adjusting the negative sign, we will get ln 5 by 2 is equal to t by tau. And from that, the value of t is 5 seconds, we already know, and ln 5 by 2 is ln 2.5, that is mentioned 4.4. And it is in log 10 basis. So we know that ln is 2.303 times of log 10 base. So we have to calculate ln of 2.5. We have log of 2.5, that is 0.4. So it will be 2.303 multiply 0.4, and it should be equal to t by tau. T is already given to us, that is 5 seconds, and tau will be equal to RC. So R into C is 2 microfarad, so 2 into 10 raised to power minus 6. Now adjusting all of these values, we will get R is equal to 5 into 10 raised to power 6 divided by 2 into 2.303 into zero point 0.4. And after solving this whole, we will get 2.72 into 10 raised to power 6. And now if we match it, then option B will be the right answer here. So with this, I end this video here. Hopefully whatever I have covered is helpful to you and understandable also. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them. And if you find this video helpful, useful, then do press the like button, share it, and subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.